Good afternoon. My name is Ravi Babu, Assistant Professor in IARE College. Today I am going to explain the pulse transfer function with zero order whole device examples, numerical examples. Already in previous section we will see the pulse, what is meant by pulse transfer function. After that one we will go for the pulse transfer function with zero order whole device. Okay. Now we are going to go seeing the numerical examples. Now consider this is the one of the numerical example. Here I am taking the pulse. I want to going to finding the for a system of that is G of S. For this system G of S. Now I am going to for this G of S. I am going to finding the pulse transfer function for the system. So with zero order O device, that is G H naught of S. G H naught of S. So when I am going to the applying the pulse function, that is in that case we consider here time domain analysis also. Time domain analysis also. So in this section I am taking as a here time domain with 1 second. Time domain with 1 second. Here R of S is the input function and pulse function is the with time period is 1 second and with zero order whole device is G H naught of S and G of S is the your system and Y of S is the output. So I am going to finding that transfer function. Which transfer function? It is containing the pulse transfer function. Pulse transfer function. That is this total function. So that is Y of S by R of S. R of S. That plot is converted into the in Z domain, that is Y of Z by R of Z. Y of Z by R of Z. Okay. So it is coming to as G into H naught of into G of Z. G of Z. Remember, this is zero order whole device. The zero order whole device S function, S domain function is not coming to here. Remember that one. It is a basic content in your previous classes. I have explained that one. So in previous sections, if you see that one is when we are going to for this one, I am taking the Z transform function. So first of all, that is for finding the transfer function for this total function, it is a single loop function. Only forward path function having the containing the one forward path function, that is G of S. It is followed with the zero order whole device, that is G into H naught of S. For that one, if you want to finding the transfer function with pulse, that is T equal 1 second. So it is coming to as Y of S by R of S. But when I am going to pulse transfer function, the S domain is I am going to convert that one into Z domain. That's why Z transform of G into H naught of S into G of S. G of S. Okay. For that one we are getting here, that is G into H naught into G of Z. G of Z. After that one, we know this value. We know this value. That is your directly we know the formula. In previous sections also we discussed about this formula. Okay. For if a function is having the pulse with respect to zero order whole device, a system is followed by pulse and with respect to zero order device, that is nothing but the transfer function formula is 1 minus Z inverse into Z of that function G of S by S. G of S by S. This is the formula for pulse transfer function with zero order whole device. Z order code device. 1 minus Z inverse into Z of the system. Which system is having here? Which system is having here? With the order of the 1. With the order of the 1. That is by S. By S. So, if you are taking this one with respect to mathematical calculation part, here Z inverse is coming to as 1 by Z. So, if you are taking the LCM here, what happened? Z minus 1 by Z into 1 by, what is the G of S value? G of S value is 1 by S into S plus 1. 1 by S into S plus 1. So, this 1 by S into S plus 1 into this S. So, it is coming to as 1 by S square into S plus 1. 1 by S square into S plus 1. So, in next step, Z minus 1 by Z into, if you are taking here for this function, partial fraction as, that is, here the order with 2. That's why it is coming to as A by S square plus B by S. Higher order terminal to lower order functions. A by S square plus B by S plus C by S plus 1. C by S plus 1. Coming for the finding the values of A, B and C. First of all, coming for the finding the value A is nothing but 1 by S into where S equal to 0. That is, okay, I want to A value. I want to A value. So it is coming to as S function, S square function. So, total what happened this one? This value is going to be cancelled. That's why S is also in terms of S square now. That's why this is a total function is 1. That is cancelled. Only the remaining part is 1 by S plus 1. That's why it is here 1 by S plus 1. After that one, how can you submit the value of S? The denominator is S square. That is nothing but S square equal to 0. That is nothing but S equal to 0. It is a partial fraction method already explained in previous classes. So many types of problems I have explained. Okay, for finding the in partial fractions constant values. So, it is coming to as S equal to 1. S equal to 1. This is for A. Here, A function is having the higher order. That's why I am taking directly. But coming to B, B is the including of the A function. B by S. B by S. So, that's why it is coming to as derivative of that one. Derivative of S plus 1. Derivative of S plus 1 where S equal to 0 also. S equal to 0. Substitute that one is, first of all, you do the derivative of the B function, that is 1 by U by V method. U by V method, it is coming to as, in derivative part it is 1 by S plus 1 no, that's why it is U by V method, it is coming to as minus 1 by S plus 1 whole square. Substitute the S value here also, 0. If you substitute the S value is 0, we are getting the 1. Okay, we are getting the 1. Sorry, minus 1. Okay, here minus is 0, we will be getting minus 1. Okay, coming for these values. If you submit these values, coming for C value, what about the C value? C value is coming as only square is coming there, S equal to minus 1 substituting. Here I am not mentioning here, C is there, yes, it is there. It is A, B, and it is A, B, and C. 1 by S square, substitute S equal to here, intersection, what is the S value here? Below the S value here, S plus 1 equal to 0, S equal to minus 1. S equal to minus 1, you get submit. You got the C value is 1. C value is 1. Now, I am rewriting the above function, Z minus 1 by this value, Z minus 1 by Z, Z into, substitute the A value, B value, C value in this function. So, we got the A equal to 1 by S square plus B value is getting the minus 1 now, minus 1 by S plus 1 by S plus 1, 1 by S plus 1. Now, I am applying here Z transform of this function for this function. Z transform for this function. So what happened? If you are applying a Z transform for this function, it is coming to as It is quieter. That's why it is coming to as tz by z minus 1. This is a formula already I explained. And for the only s, it is coming to as z by z minus 1. Okay. See, it is 1 by s, z by z minus 1. If it is quieter, one order is going to be increasing. That is what? Z by z minus 1 whole square into t. Okay. Now what happened? This one value. After that one, what is the last one? 1 by s plus 2. That is nothing but z by z minus 1 e power of minus t. E power of minus t. Here plus 1 no. That's why it is getting as minus t. These three are the formulas, previous formulas, standard formulas. So, this is coming to us here after simplification. It is as if you multiply this one inside z minus 1. So what happened? So z cancel for first term. For first term z cancel. Z minus 1 cancel. One term. So only remaining is 1 by z minus 1. Sorry, it is 1. It is not required. Okay. 1 by z minus 1. Next, coming for the second one. Multiply this one to inside. What happened? Minus 1. Third one, multiply this inside. Z cancel. Okay. Z minus 1 by z minus e power of minus t. Here. Okay. Minus t nothing but t equal to, oh sir, here sorry, square term no, it is coming to t as it. Sorry, it is coming to t, right. But t is, time period already given no, pulse function, t equal 1 second. T equal 1 second. Substitute these values. T, here, t equal 1 second. Here t equal to 1 second. If e power of minus 1 nothing but this value. E power of minus 1 is nothing but this value. Okay. Next. After that, now, taking the LCM for this one, mathematical calculation, just simple. LCM for this one, that is z minus 1, z minus 0.3679. Taking calculations, we got the value as 0.3679 z plus 0.2642. 2642. Okay. So, this is what? Only for g into h of h value. Okay. G into 0 order old device plus and forward path function, transfer function value. Okay. After that one, this value. This is your this value only. We have to find this value. You have to find this value. Completed. Next, what is it given? They want to output value also. Output value also. But in problem, they given that it is a step function. It is a step function. So, it is coming to as r of z equal to z by z minus 1. Input is step. Input is step. Step, first step, ramp, parabolic, okay, impulse. These are the signals are going to be given the input section of the every system. Every system. Why? Because these are the test signals. These are the test signals. That is, for giving the input to these test signals, we are going to analyzing the behavior of the system. Behavior of the system. So, when we are going to applying these test signals, the system behavior is going to be changing. So, we are getting the exact values of the confirmation section. That's why here I am taking the input section is in this problem as step function. Step function. For every step function, it is z by z minus 1. Z by z minus 1. So, the function is given as the impulse function is y of z by r of z equal to g into h naught of g of z. So, here y of z from this equation, y of z is coming to as r of z into this function. Okay, r of z into this function. After that one, substitute the r of z value, z by z minus 1. Z by z minus 1. So, z by z minus 1 is for total function is multiplied with previous solution. Okay, previous solution. Okay. So, we are getting here z by z minus 1 square, z by z minus 1 plus z by z minus 0.78. 0.78. This is G of H and this is G by input R1. Input R. So finally, by the solution of this one, we got as this value Z by Z minus 1 whole square minus Z by Z minus 1 plus Z by Z minus 0.3679. 3679. So now I am applying here the function. We got the function in Z transform. Now convert it into linear function. That's why inverse Z transform we have to apply here. So y of z is coming to as y of k. Y of z is coming to as y of k. And here square term will be there. That's why it is coming to as k into minus 1 of k. After that one, see, there is no square term. That's why it is coming to as 1 power of k. If square term is there, it is coming to k. Here, so here we are in the only one constant term, that is 0.3678. So 0.3678 will k. Here 1 is there. Here square term repeating now z minus 1. That's why it is coming to as minus 1 of k into k minus 1. Okay. This is the solution for this forward path. Okay. Forward path function with finding of the pulse transfer function. Okay. First step to response. Now I am going to finding the pulse transfer function. Here I am taking one more problem. That is, the system is given as g of s equal to 1 by s plus 1, 1 by s plus 1, and in this problem they given as feedback h of s equal to 1. H of s equal to 1. Okay. They given, sorry, here I not draw g of s 1 by mistake. Here g of s is there. G of s is there. Okay. G of s with 0 order over device. It is G of s there. So with pulse function is t equal to 1 and 0 order over device is g into h of s, and g of s is 1 by s plus s into s plus 1 and feedback h of s. But they given as h of s is the feedback is the 1. Okay, h of s is the feedback is the 1. So go for the same function, pulse transfer function. That is g of z by 1 plus g of z into h of z. Okay. Next. After that one, already I see apply for this one z transform. That is a by with the function a by s into s plus 1. A by s into s plus 1. Okay. This is function now a 1 by s into s plus 1. For that one I am going to apply the z transform. So 1 by s plus 1. Simple problem we use. Okay. Why? Because the given function is simple. A by s into plus b by s plus 1. So substituting for finding the a value here, a equal to, so what happened? A equal to, I am repeating once again for explanation purpose. A equal to, what is the total function? 1 by s into s plus 1 into, okay, what is the a value, below value? Yes. So this one cancel and substitute the values of s. S is nothing but, this is nothing but 0. Okay. So what happened? 1 by 0 is 1 by 2. Okay. Similarly go for b also. Okay. Similarly go for the b, we got the b value. Substitute a and b values there. So what happened? Z substituting a and b values. After that one, z transform, that is z by z minus 1 minus z by z minus e power of minus t. Here plus 1 no. That's why it is coming to us minus t. So substitute is e power of minus t. T, what is the t value they given in problem? That is 1 second. So it is coming to us z minus 0.3676. That is, it is e power of minus 1 value. We got the value of this one, like, okay. Now, see this one. G object. G object is coming to as LCM. I'm taking, after that we are getting here. After that one, for G object, that is, we got it, no? So, Y object by R object you have to find. Y object by R object you have to find. So, that is closed loop function, no? It is, that's why G of S by 1 plus G of S into H of S. H of S is 1 and G of Z value is this one. So, submit this one, we get the value. We got the value. Okay. Coming for the third problem. See this one. In previous section, there is no G of S, but now here I am taking the G of S with G of S, and function is given as only first order term, that is S plus 2. S plus 2. So, it is same procedure. First transfer function. Okay, it is Y of Z, Y of S. Y of S by R of S. Convert that one to Z transform, Y of Z by R of Z into number of forward multiplication factor, that is G into Z naught into G of S by 1 plus closed path function with unity feedback. Closed path function with unity feedback. So, G of Z by 1 plus G into H naught of G of Z value we are getting. After that one, same procedure. What is the first formula? 1 minus Z inverse of Z into 1 by that function into S. What is the function they given? G of S value 1 by S plus 2. 1 by S plus 2. S plus 2. So, it is coming to as A by S into B plus 2 by S plus 2. B plus 2 by S plus 2. Okay. So, substituting these values here, we got the A and B values. Okay. A and B values. Now, I am going to finding the A and B values, in finding of the A and B values, substituting the given function. Given function. So, what happened? Z minus 1 by Z into A by S plus B by 2 by S. Okay, B by 2 by S. So, here we got the BR is 0.5. Substitute this one here, B 0.5. Okay, we got the expression for this one, like. After that one, go for the function calculation part. We got the value of G into Z by G. Okay, so the first transaction is this one by 1 plus and G into G into H of S equal 1 here, though it is 1. So you got the 0.4333 this value. This is your first transfer function of the with a closed loop transfer function. Okay, first problem is open loop. Second problem is without G of S. Okay, sorry, unity feedback. Okay, and third problem is with G of S. Okay, so it is coming as whatever value Z minus value is this one value. Okay, now I am going to starting this one. So it is refer to Ogata book in your reference book and Q. Okay, and Q. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.